Good afternoon, this is Hein van den Berg. Today I'm presenting joint work with Boris Demarest. We would like to thank the organizers for organizing this conference, and our talk will be on Kant on scientific hypotheses, historical and systematic perspectives. We have two main topics. First, we will provide a historical overview on probability and scientific hypotheses in the 18th century German philosophy of science. And the second main topic is to give a systematic perspective on Kant's account of scientific hypotheses. These are the claims we will make. We have two historical claims. So the first one is that Wolff articulated a conception of hypothesis that was adopted with several modifications by successors. So here we can see discontinuity within continuity in the 18th century. And by contrast, there was much more divergence about the proper interpretation of probability. And the systematic claim runs as follows. Kant's views on the intelligibility of scientific hypotheses constitute an influential and valuable philosophical perspective on understanding in science. So that will be the systematic claim, and it concerns the notion of understanding in science. Here's an overview of our talk. In the first section, we will discuss Wolff and Meyer on probability and scientific hypotheses. In the second section, we will discuss Crusius on probability and scientific hypotheses. In the third section, we will discuss Kant historically on the same topics. And then we will end in the fourth section with the systematic perspectives. So let's start with the first topic, Wolff and Meyer on probability and scientific hypotheses. In order to understand their views on hypotheses, we should first give a short account of their views on science, because hypotheses play a very special role in the conception of science of Wolff and Meyer. And we can briefly say that both Wolff and Meyer adopted a demonstrative and axiomatic conception of science. So this is clear from the first quote, for example, where Wolff says, by science here, I mean the habit of demonstrating propositions. That is, the habit of inferring conclusions by a legitimate sequence from certain and immutable principles. So science is a deductive system in which we deduce non-fundamental propositions from certain fundamental propositions. And as a result, philosophy and philosophical science are completely certain. So as Wolff says, philosophy must possess complete certitude. And Meyer claims the same. He claims that Wissenschaft is ausführlich gewiss, as you can see. And so it's exhaustively certain, and that again is a consequence of deducing non-fundamental propositions from certain fundamental propositions. Now, it's important to state that this is an ideal. Not every science is completely certain in this way. However, every science should strive towards this certainty, as Meyer says in the final quote. So, wir wollen nur noch bemerken, dass wir, wenn wir unsere gelehrte Erkenntnis gehörig verbessern wollen, dahin streben müssen, dieselbe völlig gewiss zu machen. Now the question is, what role do probable cognition and hypothesis play within this demonstrative and axiomatic conception of science? Because hypotheses are not demonstrated. As Wolff says, I define a philosophical hypothesis as an assumption which cannot yet be demonstrated, but which provides a reason. And in addition, hypotheses are not certain. Philosophical hypotheses assume things which cannot yet be proven and are therefore still quite uncertain. And finally, hypotheses are opinions. They're not knowledge in a strict sense, they're not wissen. And they are a species of probable cognition. So in order to fully understand what hypotheses are, we need to say something about Wolff's notion of probability. Now, Wolff's notion of probability is defined in terms of the notions of sufficient ground and insufficient ground. And the sufficient ground is the set of all partial grounds that ground the truth of a proposition. So if you know all the grounds that make a proposition true, we have knowledge of a sufficient ground. By contrast, in the case of an insufficient ground, we know only some partial grounds of the truth of a proposition. So if we only know some grounds of the truth of a proposition, we have knowledge of an insufficient ground. And Wolff concludes that if we only have an insufficient ground for the truth of a proposition, the proposition is probable. And Meyer gives a slightly different definition of probability. He says that a probable proposition is an uncertain proposition P where we have more grounds for the truth of P than for the falsity of P. Now, what are Wolff's views on hypotheses? Hypotheses are in the first instance explanatory, so they provide a reason for things that occur. In addition, Wolff adopts a hypothetical deductive method. So we deduce consequences from hypotheses, and if the deductions agree with the experience and experiment, the probability of the hypothesis is increased. By contrast, if we deduce things contrary to experience, the hypothesis is false. Now, and then there's some additional conditions that a hypothesis should satisfy. That is that a hypothesis should be non-contradictory and not entail contradictions, and the entities implied by the hypothesis must be shown to exist in nature. And Meyer, I have not included Meyer here because his views on hypotheses are virtually identical to those of Wolff. So you can read that on your own in his Vernunftlehre. So again, how do hypotheses, which are uncertain cognition, fit within a demonstrative idea of science? Now the answer is that we can use hypotheses to obtain certainties. And this has been argued already by Corey in 1970 and by Vanzo in 2015. So as Wolff states, philosophy must use hypotheses insofar as they pave the way to the discovery of certain truth. And Meyer, in a quote here, which I won't read, argues that the Copernican hypothesis was his first hypothesis, but today it is a certainty. So the Copernican hypothesis has transformed from a hypothesis into a certainty. So we can use hypotheses to obtain certainties. However, both authors were quite clear that we do not obtain certainty through Wolff's hypothetical deductive method, which only yields greater probability. How then do we obtain certainty? Here's an example that illustrates the procedure. And this is a comment by Wolff on Hooke and Newton. Robert Hooke maintained that the primary planets gravitate toward the sun and that they are deflected from rectilinear motion. However, he could not demonstrate this hypothesis. But Newton demonstrated with the greatest geometrical rigor that because of their impressed force and gravitation toward the sun, the planets can be moved in no other orbit than an Apollonian ellipse. He also proved that the force by which the planets are deflected tends toward the sun as a center in accordance with the laws of gravity. Newton's demonstrations require a special talent and acumen and a deep knowledge of geometry and mathematics. So what Robert Hooke first maintained only as a hypothesis was later demonstrated with certainty by Newton in virtue of the fact that Newton had a deep knowledge of geometry and mathematics. So what's going on? According to Wolff, and here he is correct, Newton introduced a deduction from phenomena based on mathematical principles. So what is distinctive and what is the genius of Newton is that he reasoned in physics on the basis of mathematical principles. And because Newton adopted this method, he could attain certainty in physics. Because Wolff argues that the certainty of physics depends on mathematics. As he says in this quote, the certitude of physical knowledge depends in many ways upon mathematics. And Newton thought the same, as Walsh and Biener have argued. So if you use mathematics in physics, you obtain certain knowledge in physics. Now, why is that? The reason is that Newton used mathematics as a tool to reason deductively from certain empirical propositions to certain consequences. So mathematics is a tool to reason deductively. And here we can think of the first propositions in Book 3 of the Principia. There, for example, Newton proves mathematically that if a body satisfies the law of areas, it is subject to a central force. Then we know empirically that the satellites of Jupiter and Saturn describe the law of areas, and then we can reason deductively or conclude deductively that the satellites of Jupiter and Saturn are subject to a central force. So there we see examples of how mathematics is used as a tool to reason deductively. And because mathematics enables this, it allows for certainty in physics. So to conclude, Newton's mathematical method shows how we can transform mere hypotheses into demonstrated certainties, as Dunlop has also argued. Okay, on to the second topic, Crusius on probability in scientific hypotheses. So Crusius defines probability as follows. The property of a proposition that is a logical possibility, in virtue of which less is assumed without demonstration in positing it than in positing its contradictory. In the case of probability, the ground of cognition consists in this, that a proposition is more connected to the marks of truth than its contradictory. So here we have the definition of probability. We have more grounds of truth than its contradictory. And since necessarily one of them is true, that one should be taken to be true which matches the marks of truth more closely. So probability is therefore both relative to the grounds for holding it, as in Wolff, and relative to the grounds for holding its contradictory or contrary. And Crusius criticizes those who believe that probability arises when more of the sufficient reason for the proposition is known than unknown. So this seems to be a criticism of Wolff. And against Wolff's views, he gives a counterexample. It belongs to the nature of a square that we have 4 straight lines, 4 right angles, and finally an equality of the sides. Now, if I would be informed about a room that it has 4 sides and 4 right angles, it would have to be probable that it is square, because I would only know 2 conditions that belong to a square, and only one condition would remain unknown. But no one would say this, for it's obviously equally possible that the room is oblong. So this is a counterexample against Wolff's views. For Crusius, probability is related to deciding between alternatives. Now, Crusius discusses various sources of probability. So he argues that a proposition is more probable if it has more real possibility. And the reality of the possibility of a thing in metaphysics consists in whether it is known that sufficient grounds for it are present. Although this is not obvious from this quote, here Crusius is following Wolff, who argued that in a hypothesis, the entities that are assumed should be shown to exist. Crusius slightly modifies this condition and talks about the real possibility of entities. Crusius further argues that it is probable that that will occur which happened in previous cases that are probably similar in relevant ways. And he argues that what is incompatible with causes that have been sufficient in the past is improbable. Now, when Crusius discusses the 6th source of probability, what corresponds with the phenomena as probable, he introduces a definition of hypothesis. And that runs as follows. That proposition, however, that one assumes as a logical possibility and wants to make probable through its harmony with the phenomena is called a hypothesis. And Crusius identifies various rules for the judging of hypothesis. And the first rule is simply corresponds to Wolff's hypothetical deductive method. So Crusius argues that a proposition becomes probable if it harmonizes with the known phenomena better than its contradictory. For the harmony in connection with known facts is a mark of real possibility, hence a proposition that harmonizes better with known facts has more real possibility and is probable. So this is basically a restatement as we read it of the hypothetical deductive method. Then secondly, Crusius says that hypothesis is made more probable by a set of harmonizing phenomena than by single phenomena, because in the former case it accounts not just for each of the phenomena, but also for the fact that they harmonize. So if a hypothesis can explain the unity of phenomena, it is made more probable. So here I think we can think of the law of gravitation. Suppose we treat that as a hypothesis. That is made more probable because it explains the unity of phenomena, the tides, the comets, the planetary motions, etc., rather than just a set of individual phenomena. So it shows how they are related. And then the third condition for a hypothesis is that a hypothesis becomes less probable the more subsidiary hypotheses are required for accounting for the phenomena, since the hypothesis itself becomes more composite and therefore requires more of a coincidence. So in such a case, we could say that the probability the phenomena confer upon the hypothesis is distributed among all the independent hypotheses of which the latter consists. So what are the main elements of Crusius' statement of hypothesis? It's the focus on real possibility. A hypothesis has more real possibility, for instance, if it postulates that the ground of certain phenomena is something which we already believe to exist. And although I did not extensively discuss this, Crusius also discusses the weighing of phenomena. So Crusius seeks to derive rules for determining how much a phenomenon or a set of phenomena support a certain hypothesis. Okay, so that was Crusius, and now let's proceed to Kant. Kant defines a hypothesis as follows. A hypothesis is a holding to be true of the judgment of the truth of a ground for the sake of its sufficiency for given consequences. So first of all, hypotheses are explanatory, they specify grounds. Second, hypotheses are a special kind of opinion or mining, just like in Meyer and Wolff. And thirdly, hypotheses are probable judgments. So as Kant says, hypotheses through which we never attain apodictic certainty, but always only a greater or lesser degree of probability. And how does Kant understand probability? He gives the following definition. By probability is to be understood a holding to be true based on insufficient grounds, which have, however, a greater relation to the sufficient grounds than do the grounds of the opposite. By this explanation, we distinguish probability from mere plausibility, a holding to be true based on insufficient grounds insofar as these are greater than the grounds of the opposite. So Kant distinguishes between probability, which we can translate or which we can render as objective probability, which is not relative to our current knowledge of grounds, and verisimilitude, which is subjective probability relative to our current knowledge of grounds. Now, hypotheses, according to Kant, must satisfy a number of conditions. And the first is real possibility. As Kant states, if the imagination is to invent something, must always be fully certain and not invented, or mere opinion, and that is the possibility of the objective self. And here Kant gives his own transcendental twist to this condition. So what does this mean? In his critical philosophy, it means that hypotheses must agree with the categories, with the a priori conditions of experience. Hence, as Butts has also stressed, not any scientific guess or opinion is acceptable as a hypothesis. We can add that hypotheses must also agree with non-empirical laws. What is required is consistency with a system of laws. And as Butts illustrates this condition, what Kant needs is a criterion for the adequacy of a hypothesis that separates explanations that make events intelligible from those that are not. So Butts already connects this condition to the idea of intelligibility. It is because hypotheses agree with the categories that they are intelligible. So explanations must be based on certain a priori principles. Now, Kant also accepts a hypothetical deductive method. So as he says in the second quote, I assume something and then I see what other kinds of cognitions can be derived from this. And when we adopt this inductive method, we infer from the truth of the consequence to the truth of the ground. Now, Kant notes that this inductive inference yields certainty if all possible consequences are true. However, we do not know all consequences, hence inductively we can only approximate certainty or reach an analog of certainty. And then finally, Kant argues against the assumption of ad hoc hypotheses or subsidiary hypotheses. Hypotheses should constitute in a unity. And the reason he gives is given in the second quote. If in the case of a hypothesis, we have to have several others to help, then it loses very much of its probability. For the more consequences that may be derived from a hypothesis, the more probable it is, the fewer, the more improbable. Now, like Wolff and Meyer, Kant believes hypotheses can lead to certainty, as has also been argued by Vanzo in 2012. But we should add, we cannot arrive at certainty inductively. So here are a couple of quotes that illustrate this view. I will only quote the first one. With all hypotheses, one must necessarily secure acceptance and certainty for them in such a way that they can be confirmed and derived not merely a posteriori through relation to their consequences, but also a priori through the nexus, that is, through relation to their grounds. So we can confirm hypotheses and make them certain. And in the critique of pure reason, he gives an example. Just like Meyer, he cites the Copernican hypothesis. So there he says in a footnote, in the same way, the central laws of the motion of the heavenly bodies established with certainty what Copernicus assumed at the beginning only as a hypothesis. And at the same time, they proved the invisible force of Newtonian attraction that binds the universe. And Vanzo reads this as follows: if we can integrate hypotheses within a system of a priori and empirical principles, then we can transform hypotheses into certain propositions. So since we can integrate the Copernican hypothesis with the laws of motion and the law of gravitation, the hypothesis becomes a certainty. So that was the historical account of Kant. Let's now turn to the systematic perspectives. So Kant frequently distinguishes between denken, which we can translate as conceiving, and which means that something is thinkable without contradiction, and verstehen, a stronger notion denoting understanding, and which means that something is subsumed under the categories. So Kant makes a distinction between conceivability and intelligibility. And according to Kant, not everything that is conceivable is also intelligible. Now, what is systematically relevant of Kant's position is that Kant requires that the hypotheses on the basis of which we explain natural events are intelligible and not merely conceivable. Here's a quote that illustrates this idea. For the explanation of given appearances, no other things and grounds of explanation can be adduced than those which are connected to the given appearances by already known laws of appearances. A transcendental hypothesis in which a mere idea of reason would be used for the explanation of things in nature would thus be no explanation at all, since that which one does not adequately understand on the basis of known empirical principles will be explained by means of something about which one understands nothing at all. Now, Kant's notion of understanding differs from Hempel, because Hempel basically sees understanding simply as deduction from laws. So as in his first quote, for example, Hempel states, understanding in a theoretical or cognitive sense of exhibiting the phenomena to be explained as a special case of some general regularity. And he also states, science will not hesitate to explain even the familiar by reduction to the unfamiliar by means of concepts and principles of novel kinds that may at first be repugnant to our intuition. Now, Kant rejects this, and in this sense, he differs from Hempel, and that was already seen by Butz. So Butz summarizes the situation as follows. On the deductive model of explanation, predictability is the only intelligibility principle. Acceptance of such an explanatory basis is not wrong. For Kant, I think it would simply provide too narrow a basis for the more comprehensive kind of understanding of nature, which he thought science makes possible. So we need more comprehensive kind of understanding, and that is provided by the categories. Now, by articulating this position, Kant also argues against Hume. So here's a quote from Hume against understanding. When I see, for instance, a billiard ball moving in a straight line towards another, may I not conceive that 100 different events might as well follow from that cause? May not both these balls remain at absolute rest? May not the first ball return in a straight line or leap off from the second in any line of direction? All these suppositions are consistent and conceivable. Why then should we give the preference to one which is no more consistent or conceivable than the rest? So for Hume, conceivability is the sole constraint on scientific principles. And Kant thinks this is too weak. Intelligibility should be a constraint on scientific principles. So for Kant, intelligibility provides a constraint on hypothesizing. Hypotheses can serve their purposes as potential explanatory principles only if they themselves are intelligible and not just if they are conceivable. So the explanatory resources to which science takes recourse must themselves be explicable. And this puts Kant at odds with those Newtonians who believe the postulation of new forces without an attempt to show such forces are intelligible is a plausible path in science. And this also puts Kant at odds with Hume and those of his 20th century followers who rejected understanding as a constraint on scientific theorizing. So basically, Kant is articulating a position that understanding is central to science. And that is now more recently become a very popular position in philosophy of science. And if you want to read about this position, you can read the work of De Recht in 2017 for a discussion of understanding in the philosophy of science. Now, to conclude, Kant also rejects the use of hypothetical reasoning beyond the scope of empirical science. So here's a quote that shows this. Order and purposiveness in nature must in turn be explained from natural grounds and in accordance with laws of nature. And here even the wildest hypotheses, as long as they are physical, are more tolerable than the hyperphysical hypothesis. That is the appeal to a divine author, which one presupposes to this end. For that would be a principle of lazy reason, at once bypassing all causes of whose objective reality, at least as far as possibility is concerned, one could still learn through continued experience. So philosophical and metaphysical hypotheses have no real possibility according to Kant, and therefore the use of the canons of inductive inference in natural theology is illegitimate. So, to conclude, Kant contributes to the demarcation between scientific and philosophical reasoning. A canon of inference that is rational and permissible in science may not be so in philosophy. And Kant thus distinguishes between what is rational in science and what is rational in philosophy. Propositions that are inadmissible in science may nevertheless be rational to uphold, only not as hypotheses, for example, God or the domain of Glauben. And that ends our presentation. Here are the references.